are on lesson 2 of unit 7. This is standard form of quadratic functions and graphing them from this form. The thing about quadratics that you might not be used to is the fact that they are shown in so many forms. They could be written in so many different ways. So you're just going to kind of have to become familiar with each way and how it's written and how you can use that way to graph the function, because they are a little bit different. So first off, make sure you know that standard form is y equals ax squared plus bx plus c. That is, first off, the biggest thing you have to know, and especially the fact of identifying what a, b, and c are, because if you can't, this way is very difficult. So starting off with these 3 graphs, I just want to identify the vertex for each graph. So looking at them, remember the vertex is the turning point, and that is down here for this one, and down here for this one, and down here for this one. All of these just open up. Now, with that vertex, we want to draw in our axis of symmetry. And so keep in mind, axis of symmetry is just a line that we don't actually draw on the graph most of the time, but it would just be cutting that parabola in half. Okay, and so that means it, guess what, goes through the vertex. Boop, 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 boop. And all of these, since we have to write the equation, would be x equals something. And so for this one, it would be x equals, let's see, I'm on my axis, so that's at x equals 0. For this one, my x-axis or my y-axis is right here, and so this is at x equals -1. And then for this one, my y-axis is over here, so that's at x equals -2, because I had to go right to from that axis. So from there, what we want to do is calculate the ratio -b/2a for each equation. Now, -b/2a might sound somewhat familiar, and that's good because it comes from the quadratic formula. In case you don't remember the quadratic formula, it is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And there are 1.5 billion different ways we can sing that. You've seen that in person if you've seen me in person. But that's a whole other thing for a whole other video. Anyways, doing -b/2a with this first one, I don't have an x term, and you notice in standard form, b is the number that's in front of just the x, and so that means I have 0. And so -b/2a would just be -0, which is still 0, over 2 times 2. And really, it doesn't matter that I have 2 times 2 on the bottom, because that means my ratio is at 0, okay? If I do -b/2a with this one, my b is a +4, and so +4 would become a -4 over 2 times 2, and then 2 times 2 is 4, so it'd be -4 over 4, which is is -1. And then with this last one, -b/2a, we would have -8 as our b, which is a +8 for -b, because remember, you just switch the signs of it. And then 2 times a, which is 2. And so that would give me 8 divided by 4, which is 2. And so from all of that, how is the ratio calculated, that -b/2a, related to the axis of symmetry? If you notice, oops, I wasn't trying to do that. So if you notice, x equals 0, -b/2a gave me 0. X is -1, -b/2a gave me that -1. And x equals 2, well, -b/2a gave me that too. So guess what? If you want your axis of symmetry, you have to find the vertical line x equals -b/2a. You just find your b and find your a and plug it in. Okay, now the thing that's kind of tricky, and keep in mind that that is a vertical line, that your vertex is going to be an ordered pair where the x value is that -b/2a, what you literally just calculated for, and then plugging in that to the function. And so this notation right here, this f of -b/2a, all that really means is plug in -b/2a for x and solve for y. Because remember, f of x is just saying the function at x. Where is y when x is this? Okay? Put a little box around it. All right, so another vocabulary. Oops, don't want that box to move. Another vocabulary piece is an increasing function. And when you have an increasing function, that means it is going to be going up. Your y values will be increasing. And so it has a positive rate of change or a positive slope. Now, if it is a decreasing function, then that means it's going to be going down, and that means that y is decreasing and has a negative rate of change. Okay, so when we look at example 1, we want to consider the function f of x equals 5x squared minus 20x minus 1. So first off, decide, does the graph open up or down? Well, if you recall from the first lesson, we are looking at our a value when we're doing that. And so because this is a positive 5, we know that this is going to open up. It's going to be a normal regular parabola. Boop, like that. Okay? Now, to get our axis of symmetry, remember that's just negative b over 2a. So we plug it in. If we look at this, A is 5, B is negative 20, and C is negative 1. And so when we have negative B, that would become a positive 20 instead of negative 20. And then over 2 times 5. And 2 times 5, as you very well know, is 10, and 20 divided by 10 is just 2. So therefore, my axis of symmetry is at x equals 2. And I'm going to abbreviate it AOS. Okay, and so then to calculate the coordinates for the vertex, I already know I need to plug in x equals 2, so I'm going to say the function at 2, f of x, is 5 times 2 squared minus 20 times 2 minus 1. Don't be scared of function notation. All it's telling you is what to plug in for x. This f of a number just is saying this is y. Okay. So from there, we would say f of 2, we're just following order of operations. 2 squared is 4. 4 times 5 is 20. Minus 20 times 2 is 40 minus 1. And so then 20 minus 40 would give us negative 20. And then minus 1 would give us negative 21. Oops, I did not plug in a negative 2 though. Oops. Okay, so f of 2 equals negative 21. And so what that means for you is that your vertex, and this is why function notation is nice, is at 2, negative 21. You just take your number that was in your first, or with your f, and that is your x value, and then your y value is whatever you get at the end. Okay? So, moving on down. Oops. Of course it did that. So, moving on down with when we are graphing a quadratic function, we are going to start by calculating the axis of symmetry. So that is your negative b over 2a. Okay. Then you're going to calculate, so you're going to plug in your axis of symmetry number. Then you're going to make a table of values using 2 x coordinates to the left and right of the vertex, and then plot those points to finish them. So just kind of an example, if I said my axis of symmetry was at, let's say, x equals, I don't know, 3, then that means in your table you'd want 2 and 1 and 4 and 5. You're just picking numbers that are directly above and directly below wherever your axis of symmetry is. Okay? So we're going to graph some now. Woohoo! So exciting. So we're going to get that axis of symmetry and vertex in order to graph these. So starting off, we have f of x is negative 2x squared plus 3. I would recommend that you guys just get in the habit of writing what a, b, and c are, just because it helps make sure you don't make silly mistakes. But in this case, we do not have a middle term, and so that means b is 0. And then c is our constant, which is why it starts with c partially, but c is the constant, and so that means it is at positive 3. So then, if I am finding my axis of symmetry, we are going to plug in x equals negative b over 2a. Negative b is just 0 over 2 times negative 2. But again, if 0 is in the top, you just know your axis of symmetry is at 0. Okay, and so you can, if you want, to draw in that dotted line. Okay, so then our next step is to plug that in. Oops, these colors are not changing very quickly. So plugging that in, we would have f of 0 equals negative 2 times 0 squared plus 3. And when we do that, f of 0 gives me 0 plus 3. So then that means f of 0 is 3. And so again, remember, this is your vertex, and function notation is nice because it gives you the x value first and the y value next. So this is our vertex, and we go ahead and plot that 0, 3. And then we make a beautiful table of values. Oops, there it goes. If my colors would switch. But we make a nice table of values, and what you can do with this is if you know that 0 is your middle, then you just write that in the middle, and you already know your y value is 3, so you can put that in there. And then in this case, we're still using negative 2, negative 1, 1, and 2. So if I plug in, let's say positive 1, because remember, this is an axis of symmetry, you technically only have to plug in half of these numbers, and it's going to curve back up. So at 1, you would have 1 squared, which is 1, times negative 2, which would be negative 2. Negative 2 plus 3 would give me a negative 1. Okay? And so then if we plug in 2, we would have negative 2 times 2 squared. Okay? And that would give us 4. 4 times negative 2 is negative 8, and negative 8 plus 3 is negative 5. Okay? And so then this would have negative 1 and negative 5, and we can plot these points. We would be negative 1, negative 1, 1, negative 1, and 2, negative 5. Now, in case any of you are like, but how do I know if I'm right? You have a couple options. You have a graphing calculator that you could type this equation into just to see if it turns out to look the same, or you can think about it logically. We know that what that negative 2 means. That means it opens down, which the graph does open down. And then this 3 out here tells me that it shifted up 3, which it did. So we are good to go. Okay? So for the next one, boop, we're going to do the exact same thing. We're going to start by finding our axis of symmetry, which remember is negative b over 2a. Now, in this case, a is 1, and that should tell you some stuff about what you should expect to see from this graph. Okay? Because remember, if a is 1, that means it's going to open up because it's positive, and it's going to be just as wide as any other normal quadratic like x squared. So plugging in, we would have x is negative b, so negative 4, over 2a, so 2 times 1. And so then negative 4 divided by 2 would just give me negative 2. And again, that is your axis of symmetry. And so on your graph, if you want, you can go ahead and draw in that dotted line. Okay? So then remember, you take that number and use it for your next step because you're going to plug it in for x so that you can find your vertex. So f of negative 2 is negative 2 squared plus 4 times negative 2 minus 1. And so then f of negative 2 squared is positive 4, and positive 4 times negative 2 is negative 8. And so 4 minus 8 is negative 4. Minus 1 is negative 5. Okay, and so then that means my vertex is at negative 2, negative 5. So negative 2, 1, 2, 3, 4, 5. Okay, and so then last but not least, we are filling in this table of values. Remember, you want to use the x value from your vertex again. It gets used in every step after. Okay, so if I'm at negative 2, count up. Negative 2, negative 1, 0. And then we're going to count down to negative 3 and negative 4. So we know at negative 2, it's already at negative 5. If I plug in negative 1, and since these are some uglier numbers, I'm going to write it out. But we would have negative 1 squared plus 4 times negative 1 minus 1. Negative 1 squared is positive 1. 4 times negative 1 is negative 4. And then that minus 1 just gets to stay. So 1 minus 4 is negative 3. And negative 3 minus 1 is negative 4. Now again, the nice thing, These are quadratics, which means you only have to plug in one side. Okay? So then we're going to plug in the next number, which would be 0, which makes our life really easy, but that would be 0 plus 0 minus 1, so that's at -1. Now here's the thing. Use your graphing calculator to make sure it looks right, or plug in the numbers and make sure they are actually mirror images of each other. Okay, so then we would have at -1, -4, and at 0, -1. And then mirror image. Okay, like that. Okay, so from there, we're going to do the same thing. Example 4. Still going to find our axis of symmetry first. So that would be x equals -b over 2a. In this case, a is -3, which alarms in your head. Negative means it's going to be upside down, and 3 means it's going to be narrower. Okay, so then b is at 6 and c is at 9. So for -b over 2a, we would have -6 over 2 times -3. And 2 times -3 is -6. And so then we end up with x equals +1 for our axis of symmetry. Okay, and so on the graph, you can do a little dotted line. Boop, 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 boop. Okay. So then to get our vertex, we are going to plug in that x equals 1. And so we would have f of 1 equals -3 times 1 squared plus 6 times 1 plus 9. So again, 1 by 1, 1 squared is 1 times -3 is -3. 6 times 1 is 6, and then plus 9. So then f of 1, -3 plus 6 is +3 plus 9, which is 12. So our vertex would be at 112. Okay. And on this graph, 2, 4, 6, 8, we want to actually fit on the graph. So since it's 8, let's just count by 2s. We'll say this is 16 and 16, -16, -16. So then at 112, that would be, let's see, every line's now worth 2. Oh, man. Since I changed my scale, I have to move my axis of symmetry now. Boo. But since I changed my scale, we could do it like that. No big deal. But we would have at 1 +12, so 1 or 2, 4, 6, 8, 10, 12, we would have our point. And then we are going to be graphing the rest of this. Remember, it's negative, so it opens down. And so then if you think about our table of values, we are starting at 1, which means I can go to 2 and 3, and we have 0 and -1. So at 1, I know it's at 12. If I plug in 2, I end up with -3 times 2 squared plus 6 times 2 plus 9. And so 2 squared is 4. 4 times -3 is -12. And then 6 times 2 is +12 plus 9 gives me +9. And then doing the same when we plug in 3. 3 squared is 9, and 9 times -3 is -27. 6 times 3 is 18, and then plus 9. So -27 plus 18 is -9, plus 9 gives me 0. Okay, and so then we are at 2, 9. So 2, 2, 4, 6, 8, 9. And again, be careful of your scale. And then at 3, 0. And -1, 0. Okay, so it does make this graph a little bit narrower than it normally is. Boop. It's kind of hard to fit. All right. So for our next one, we have a ball being thrown into an air with an upward initial velocity of 48 feet per second. And its height, h in feet after t seconds, is given by the function h of t equals -16 t squared plus 48t plus 4. So first, in how many seconds will the ball reach its maximum height? Well, first, you got to think about a parabola in general. If I have a parabola, that has a negative 16 t squared, I know it's going to go up and it's going to come back down, right? So because of that, knowing that it goes up and down, I know that reaching its maximum height means that's the maximum point on the parabola, which is the axis of symmetry. And the axis of symmetry sits on the x-axis. And in this case, time would be our x-axis. And so that means all I have to do for this is to find the axis of symmetry. So for me, that means I'm going to say t instead of x because t is time, or x is time. But t equals negative b over 2a. In the function, my b is 48, so my t is going to be negative 48 over 2 times my a, which is 16. Well, now that's going to be an ugly number probably, but you pull out your calculator. 2 times negative 16 is negative 32, so you have negative 48 divided by, and P.S., if you want to multiply, you can put 2 times negative 16 in parentheses and it'll be fine. Okay, but when I hit enter, that gives me 1.5, which means it reaches its maximum height at 1.5 seconds. Okay. So then what is the ball's maximum height? That's going to be the y value of the vertex. And so that means I'm going to have to take this h of t and plug in 1.5. So we would have negative 16 times 1.5 squared plus 48 times 1.5 plus 4. And so this is where we're going to show you some graphing calculator magic, because I can do 1.5 squared pretty easily. Okay, and then you can multiply that by negative 16. Honestly, it's better just to go ahead and do this kind of the slow way, so to speak, because then you get negative 36 plus, do your parentheses, 48 times 1.5. Close your parentheses, enter, plus 4. And that gives us 40. And so that means at h after 1.5 seconds is at 40 feet. Okay. So then we want to describe some characteristics of the graph of f of x equals negative 2x squared plus 8x plus 1. So we can do a few characteristics. First off, we know it opens down because of that negative 2. And so that's going to have a maximum. We can find that maximum, or our axis of symmetry, by doing negative b over 2a, so that would be negative 8 over 2 times negative 2, and so that would be negative 8 over negative 4, which is positive 2, is our axis of symmetry. And then we can even go farther and plug in 2 to find our vertex, but I'm not going to make us do that right now. And then with this graph, it would kind of be like the one up here, but again, you can plug it in. Okay, so keep in mind, we are going to keep building on these characteristics of graphs. We're going to be talking about when functions increase and when the functions decrease. We're going to be talking about all of this stuff coming up. Okay, so just keep that in mind as we're going through these notes for this unit, that all of this is going to be relevant and used in other sections. Okay, so if you have any questions, put a comment below. If the video is helpful, give it a like. If you want notifications when more stuff is made, you can also subscribe to the channel. But we will see you guys later.